Hello dear viewers, you are on the Krasmodo channel. What do we imagine when we hear the term opposed engine? The first thoughts are BMW motorcycles, Honda Goldwing, domestic Dnipers and Urals. By the way, the first motorcycle I ever rode and learned to operate was my grandfather's INZ. What else is there? Subaru cars, Volkswagen Beetle, the T64 tank, and small aviation. However, the history of these engines is far more interesting and extensive. In this episode, I invite you to hear a few words about boxer engines. We'll figure out what a boxer engine is, when and by whom it was first built. What are the pros and cons of such an engine? We'll also take a look at the most interesting and unusual motorcycles with this type of engine layout. Yes, we'll mainly focus on motorcycles, but to understand the topic as a whole, there will also be some context from engine building, the automotive industry, shipbuilding, aviation, and other fields. So I won't drag it out. Make yourself comfortable and enjoy watching. Before discussing the terms, let's clarify one thing. There are some people who recognize only engines with two pistons in a cylinder as opposites, but it all depends on the sources of classification. An opposed engine is a piston internal combustion engine in which the angle between the rows of cylinders is 180 degrees. However, that's not all. In the animation, there are two engines with a 180-degree cylinder bank angle. So what's the difference? The guy on top is an opposed engine and its pistons move in a mirrored fashion relative to each other. Accordingly, they reach top dead center at the same time. And the lower engine is a V-type. In this setup, when one piston is at top dead center, the one opposite it is at bottom dead center. The name of this engine in English is horizontally opposed engine, and it's also called a boxer engine. As for the term, it is used for both opposed engines and V-type engines with a cylinder bank angle of 180 degrees. And this is probably due to confusion, since even some serious foreign sources firmly state, here is a horizontally opposed engine and here is a flat engine. The opposed engine, or boxer if you prefer that name, is the one we are most familiar with and used to. Yes, opposed engines are the most common type of engine with this configuration. This engine configuration is used in the BMW Goose, Subaru Impreza, and the old Douglas motorcycle. However, there are a few more interesting variants of the opposed engine. The first one in English sounds like opposite piston, opposite cylinder. In our language, it's called an engine with opposed piston movement. An engine with opposed pistons is a piston engine, pardon the pun, in which each cylinder has a piston at both ends and does not have a cylinder head. We'll talk about it in more detail in the next chapter. The second is a free piston internal combustion engine, or a free piston engine. It's hard to classify such an engine as an opposed type, although there are designs that resemble the concepts of UP and UC. The purpose of such an engine is to generate energy. In a free piston engine, this power is not transmitted to a crankshaft, but instead is extracted either by the pressure of exhaust gases driving a turbine or by driving a linear load. For example, a linear alternating current generator that is integrated directly into the engine. So in general, it seems we've figured out what an opposed engine is. Is there anything to add or correct? Please let me know in the comments. The opposed engine appeared during the evolution of internal combustion engines as an absolutely logical development. One of the first, if not the very first, opposed engines was designed by our compatriot Ogneslav Stepanovich Kostovich, who, in the early 1880s, first built a demonstration model and later a full-fledged engine for the airship Rossia. However, the airship was never built. The fuel was mixed with air in something resembling carburetors, one for each pair of cylinders. The displacement of the unit is not specified, but its power is known, 80 horsepower at 400 revolutions per minute. I should note that Kostovich's engine cannot be classified as a UPU SE type, since there is still only one piston per cylinder. One of the first opposed engines with two pistons in a cylinder was Atkinson's differential engine of 1882, which had a power stroke with every revolution of the crankshaft, compared to every second revolution in a modern engine with the Otto cycle. But it did not achieve commercial success. In 1898, a two-stroke Ohelcos engine with opposed pistons and a power output of 600 horsepower was installed at the metallurgical plant in Hord. This engine design was also produced under license by manufacturers such as Deutsche Kraftgasgesellschaft in Germany and William Beardmore and Sons in Great Britain. In 1900, such an engine was built by the French company Gobron-Brillier, and in July 1904, a Gobron-Brillier automobile equipped with an engine with opposed pistons became the first car ever to exceed a speed of 100 miles per hour. The record was 106.665 kilometers per hour, and it was set on a beach in Belgium by the racer Louis Regali. The engine used a single crankshaft at one end of the cylinders and a crosshead for the opposite piston. A similar engine was also installed in the Scottish car Arroll Johnston in the early 1900s. The engine was described in detail and illustrated in the report about their 1215 horsepower car, which was exhibited at the Olympia Motor Show in 1905. The engine was a four-stroke with two cylinders, each having opposed pistons. Subsequently, this layout was named opposite piston, opposite cylinder. The advantage of such engines compared to others was the elimination of the cylinder head, reduced heat loss and friction loss in the engine, as well as the creation of a straight-through gas flow through the combustion chamber. However, there was also a major drawback. The two pistons need to be mechanically connected somehow, and this greatly complicates and burdens the design compared to conventional piston engines, which use a single crankshaft. Due to their bulkiness, such opposed engines found application in heavy machinery and industry, on ships, submarines, and in some tanks. However, they have been used a few times in aviation throughout their history. For example, in 1932, the Junkers Jumo 205 diesel aircraft engine was developed. And judging by this photograph, the German company NSU even managed to equip a motorcycle with such an engine. Aside from the photograph, which doesn't clarify much, there's no other information about it online. And this fact remains a big question. A very interesting construction on the topic of opposite piston, which I just can't ignore, appeared in 1954. That year, the Napier Deltic engine was produced for military boats. It uses three crankshafts, one at each corner, to form three rows of double-sided cylinders arranged in the shape of an equilateral triangle. The Deltic engine was used in British Rail Class 55 and 23 locomotives, as well as in high-speed patrol boats and minesweepers of the Royal Navy. The more familiar and well-known to us opposed, or as they say, boxer engine was first developed somewhat later than the opposed piston designs by a German man at the end of the 19th century. In that era, cars were rare and luxurious, not just in Germany, but throughout the developed world. However, this did not stop the few car owners from indulging their expectations for increased power and speed. These trends were timely recognized by a talented engineer and pioneer of automobile manufacturing. In 1896, he established a special department for automobile engine design at his company in Mannheim and began developing efficient multi-cylinder designs. And a year later, the company presented a new engine concept. And the talented engineer was named Carl Friedrich Michael Benz. Thank you, Grandpa Benz, for a happy childhood. It was Benz who came up with the layout in which the cylinders are arranged on both sides of the central crankshaft. And this engine architecture turned out to be quite successful and fairly compact compared to other types of opposed engines. Over the next 2 years, Benz's engineers brought this so-called counter-engine up to production standards. And already in 1898 they were installing 4 and 2-liter versions of it on buses. Fully refined opposed engines with displacements of 1.7 and 0.713 United States gallons producing 5 and 8 horsepower respectively, finally debuted on the Benz Dos a Dos automobile in 1899. 3 years later, aviators turned their attention to the opposed engine. In 1902, the monoplane of Peirce, which would later become one of the first airplanes to make a flight, was equipped with a 2-cylinder opposed engine. To this day, the opposed engine is the most common motor in amateur small aviation, and all thanks to its advantages. It is one of the most economical in flight mode, well balanced, and has high torque at low speeds, which allows it to be operated without a gearbox. The opposed engine will debut on a motorcycle in 1905. But more about this later as the story unfolds. Some foreign sources give the credit to the Holden motorcycle. This is quite an unusual design, conceptually similar to the first mass-produced motorcycle by Hildebrand Wolfmüller. On both of them, the force was transmitted to the rear wheel by connecting rods. Yes, just like on steam locomotives. Colonel Capel Holden built his first 4-cylinder steam motorcycle in 1895 and 2 years later created a version with a 4-cylinder internal combustion engine, which in 1899 was equipped with liquid cooling. These were extremely bold designs for that time. And yes, Holden's motorcycle was the first 4-cylinder motorcycle in human history. But the 4-cylinder engine of these machines was not an opposed engine, it was a flat V-type. The first motorcycle in human history equipped with a boxer engine was called Fay and was produced by Light Motors Company in 1905 in Britain. The machine was soon renamed to Ferry after its appearance. This motorcycle had a 200cc 4-stroke boxer engine. Interestingly, the motorcycle industry only started using 2-stroke boxers 4 decades later, and even then, just in a few models. We need to make it 4-stroke so we can go 1, 2, 3, 4. We don't give a damn about the fuel. And this engine placement in the motorcycle frame remained unchanged for 2 decades. Let me explain what this is related to. In fact, early motorcycles were basically bicycles with a small engine, and for some time they didn't have gearboxes at all. So, in order to transfer power from the crankshaft to the wheel using a belt or chain drive without any gearboxes, it was necessary to position the engine with the crankshaft at an angle to the motorcycle. And while single-cylinder and V-twin engines fit quite harmoniously into the design, the boxer engine was rather bulky. But nobody cared about that, just like they didn't care about the motorcycle's increased wheelbase or the rear cylinder's insufficient cooling. It took time for the design to evolve. The first motorcycle where the opposed engines were arranged the way modern people are used to, that is, with the cylinders across the frame, was a machine designed by Grenville Bradshaw. It was a 400cc motorcycle produced in 1919. According to other sources, a prototype from this company had already appeared in 1916. In 1907, Light Motors Company, the one that produced the world's first opposed motorcycle, shut down. But before that, it managed to transfer motorcycle production to Douglas Engineering Company, one of its suppliers. And yes, the Douglas Company was quite successful in producing motorcycles with opposed engines, which it manufactured for 50 years, right up until 1957. At first, the engines were installed with the cylinders along the frame, and only from the mid-1930s were they mounted transversely. The company from Bristol actively supplied motorcycles to the British Army during World War I, about 70,000 units. In the early 1920s, for the first time in human history, a motorcycle was equipped with disc brakes and performed extremely actively in races. Douglas is one of the most successful boxer manufacturing companies of that time, and many looked up to it. In fact, starting from the 1910s up to the beginning of World War II and into the first post-war decade, almost everyone except the lazy was making motorcycles with such an engine. I won't go into detail about each one, because I don't want to turn the story into something boring. This partial list includes boxer motorcycle manufacturers from the early 20th century, such as British brands ABC, Douglas, Brough, Bradbury, Humber, Montgomery, Williamson, and Matchless, German brands Mars, Victoria Hoffmann, Sundap, Helios, and BMW, American brands Indian and Harley-Davidson, Czechoslovak brand ITA, Belgian brands FN and Sarolea, and French brands Gnome Rhone and René Gillet. I'll elaborate on select motorcycle models. BMW will be covered in a dedicated chapter. So many people know about the two American giants in the world of motorcycles, like Harley-Davidson and Indian. This machine's image is strongly tied to Vetvinom. And some of you might be surprised that these brands tried to equip their motorcycles with a boxer engine. It should be noted that these were not entirely successful experiments. Indian model OU was a lightweight motorcycle produced from 1917 to 1919 and was aimed at a young audience. The model OU, equipped in the style of Douglas with a two-cylinder 257 cubic centimeters boxer engine producing 4 horsepower, replaced the K featherweight model with its two-stroke single-cylinder engine in the lineup. The model did not gain popularity and was unprofitable. A whole range of situations played a role here. The OU model debuted in 1917 when the United States entered World War I. Indian redirected its efforts to selling motorcycles specifically to the military. The appeal of lightweight motorcycles as transportation was also undermined by the availability of mass-produced automobiles. The Ford Model T was synonymous with mass-produced automobile in that era. Therefore, in 1919, the OU model was successfully discontinued. After that, Indian never installed boxer engines on their machines again. In the same year, when Indian breathed a sigh of relief after getting rid of their boxer model, the guys from Harley and Davidson decided to step on the same wreck. William Harley and the Davidson brothers introduced the Model W, which was positioned as a medium weight and medium displacement model for beginner racers. On the outside, the motorcycle repeated the features of the British Douglas. The design that Harley came up with turned out to be quite interesting. The 6-horsepower, 584cc flat-twin engine had a 3-speed gearbox and a wet clutch in the same unit as the engine. The engine also served as a stressed member of the frame. The W model turned out to be very durable. Hep Scherer, Harley-Davidson's advertising manager, set endurance records on rides from British Columbia to Tijuana and from New York to Chicago. In July 1919, the W model became the first motorized vehicle to climb Mount San Antonio, California. However, the commercial model turned out to be unprofitable. In 1920, a year after the W model appeared, Indian began offering its Scout to the masses. With similar dimensions, it was faster and more popular. Moreover, the W model cost more than a used Ford car and was about as expensive as the 1-liter V-twin from Harley and Davidson. Despite decent sales of the W model in Europe, by 1923 its production was discontinued. Once again, the company Harley and Davidson would be associated with a horizontally opposed engine during World War II with the Model XA. At that time, the company received a specific assignment from the United States Army to develop a motorcycle with increased off-road capability for use in North Africa. Important requirements for use in desert conditions were a shaft drive for the rear wheel and more efficient engine cooling than the V-twin of the WLA model. The model was named EXA, which stood for Experimental Army. John Novak, the designer of this machine, had heard about BMW motorcycles and their successful use in the campaigns of the African Corps. John took the path of least resistance, practically copying the XA from a captured BMW R7-1 motorcycle. Some sources mention the BMW R12, but it's not crucial. In 1942 and 1943, about 1,000 of these Harleys rolled off the assembly line. Let's go back to Europe in the period between the World Wars. During this period, Germany became one of the centers of active motorcycle development. And this was despite the defeat in the First World War and the subsequent period of hyperinflation in the early 20s. German industry gave the world a whole range of companies and many models of boxer motorcycles. One of them, and one of the earliest German ones, is Massa 20. The motorcycle, created at the Masswerke factory in Nuremberg in 1920, incorporated a lot of innovations of that time. Massa 20 is a legend among German motorcycles. It didn't have a frame in the usual sense of the word. The basis of the machine was a box-shaped load-bearing frame which housed the fuel and oil tanks as well as a storage box. Under the frame was a longitudinally mounted side valve opposed two-cylinder Maybach engine. With a working volume of 956 cubic centimeters and a power output of 7 3/10 horsepower, it was equipped with an external flywheel, which also served as the fan for the forced air cooling system. The engine was started in an automotive manner, using a rotating handle through a special drive. And yes, many opposed motorcycles of those years were started in the same way. Constantly being modernized, Mars was produced until 1933. In total, just over 1,000 units were made. I should note this was a very expensive motorcycle for its time. Another company from Nuremberg, Victoria Werke, also presented its first opposed motorcycle in 1920. This was the model KR1, which was equipped with the engine MDV AB15 from BMW. However, later, BMW stopped selling its engines to Victoria, and the latter lured Martin Stolli from BMW to design similar engines for Victoria. Here's something interesting. The opposed Victoria motorcycle in 1925 became the first German motorcycle with forced induction. And on this machine, Adolf Brutz sets a new German speed record, 166 km per hour. In 1931, the Victoria Company's motorcycle with an opposed engine wins the European Hill Climb Championship in the sidecar class with an engine up to 600 cubic centimeters. It was the 20 horsepower model KR6. A story about Victoria's history was recently released. A suggestion was made for it. Another well-known German company, Zundap, began its history with Boxer engines in 1933. That year, 3 models of Boxer motorcycles were introduced at once. The smallest was the Model K400 with a 10 horsepower engine. It stayed on the assembly line for only a year. The second model, K500, was equipped with a 16 horsepower Boxer engine and remained in production until 1940. Many units of the K500 and older Zundap models were used by the German army at the beginning of World War II. At first, the 4-stroke engines had a side valve timing mechanism, and only in 1936 did an overhead valve version of the 500 appear, the KS500 model. Its 20 horsepower engine accelerated the motorcycle to 130 km per hour, but the KS500 was not suitable for use with a sidecar. In 1938, the company offered a compromise option, the Zundap KS600. By increasing the engine displacement to 596 cubic centimeters and installing a single carburetor instead of 2, the engineers accomplished 2 tasks at once. They significantly increased the engine's torque at low revolutions per minute and at the same time improved its output at high revolutions per minute up to 28 horsepower. The reinforced chassis responded better to the tough operating conditions with a sidecar. Zundap Boxer engines are often compared to BMW. The engines and frames of these machines have obvious external similarities, but in detail they are completely different machines. The crankshaft of the Zundap KS600 engine rotated in 3 main bearings, 2 roller bearings and 1 plain bearing. The connecting rods were mounted on it with roller bearings equipped with cages. The camshaft was located in the upper part of the crankcase, and its drive was carried out by gears made of Novatex material. This synthetic composition, reinforced with flax fiber, although it was a bit brittle, provided a low noise level. A conical gear was introduced into the Kickstarter mechanism, so the engine did not have to be started sideways. As with BMW, the 2-disc clutch operated in an oil mist. The 4-speed gearbox had an extremely extravagant design. The 600 model was produced from 1938 to 1941, and from 1949 to 1951 it was produced as the KS601 model. The crowning achievement, and the third model presented in 1933, was the Zundap K800 motorcycle with a 4-cylinder side valve opposed engine. The model was produced up until 1938, and a little over 7,000 units rolled off the assembly line. The K800 was equipped with a 4-cylinder, opposed air-cooled engine with a power output of 20 horsepower. And both externally and internally, it represented a very well-designed and beautiful construction, but it was also very expensive and complex. The army version of the K800W was especially favored by soldiers, but this model often had issues with the rear cylinders due to insufficient cooling, causing the spark plugs to get fouled with oil. the Wehrmacht had about 550 units of the K800W in service. The K800 was and remains the only four-cylinder motorcycle ever used by the German army. Now we've arrived at a fascinating model, the Zundap K750. This military motorcycle was developed specifically for the Wehrmacht at their request. And what kind of engine does it have? Huh? Opposed? V-twin? If you look at the cylinder angle, it seems like a V-twin. But if you look at the crankshaft, it looks a lot like an opposed engine. So where is the truth then? Here you need to look at where the roots are. The KS750 engine was designed based on earlier Zundap opposed engines, and in the case of the KS750, the cylinder bank angle was deliberately made 170 degrees to increase the clearance from the cylinders to the ground. It's a military motorcycle designed for tough road conditions. But in terms of operation and the angle between the crank pins at 180 degrees, it still remained an opposed engine. There was just a bit more vibration. Now, I'll discuss another opposed engine with a cylinder bank angle other than 180 degrees. Maybe that phrase sounded like the rambling of a madman, but I hope you caught my train of thought. This motorcycle is the Austrian Puch P800. In the 1930s, the Puch company made great efforts to sign a contract with the Austrian government to supply their motorcycles to the army. Giovanni Marcellino, a pivotal figure in the company's history, developed the four-cylinder Puch P800 model for these goals in the mid-1930s. But this technical marvel did not interest the military. Despite the failure with the military contract, in March 1936, the new Austrian motorcycle was presented to the general public at the Vienna Spring Fair. Giovanni Marcellino was not a supporter of half measures. Knowing about this trait of his boss, Alfred Oswald, the head of the Puch engineering department used all the capabilities of his team to outshine the renowned competitors. The four-cylinder side valve engine looked somewhat unusual, but it had all the features of a boxer engine. The four pistons move in a mirror-like fashion towards each other, and the angle between the connecting rods is 180 degrees. But here, the main feature of the brand appeared, an extravagant solution. Each pair of cylinders changed its tilt by 16 degrees relative to the horizontal. The total angle between the cylinders was 148 degrees. This allowed the lower edge of the cylinder block to be raised by 80 millimeters. At this point in the story, you might giggle and say, wait, at the 2-minute and 25-second mark of this episode, you said that a boxer engine is always exactly 180 degrees? Yes, that's right, 180. But there is an exception to this rule, and this exception is two models of motorcycles, Zundap KS750 and Puch 800. By the way, about the Puch company, they developed their first horizontally opposed engine in 1898. And also at the end of the 40s and the beginning of the 50s, the company released the model Piazzot SGS, which did not go beyond the experimental stage. Now I want to say a little about the British company Wöhler, which produced motorcycles from 1900 to 1955, and since 1919 they produced opposed engines. Actually, the opposed engines of this company were quite similar to the technology of Douglas. We are interested in two motorcycle prototypes from this company from the late 40s to the early 50s. So, on February 16, 1948, Wöhler presented their Lightfoe prototype to the press. The engine had an interesting layout. It was a four-cylinder and in fact consisted of two joined V-twins with a cylinder angle of 180 degrees. Instead of two crankshafts, they used two pairs of short connecting rods, which rotated on a central T-shaped beam. The upper and lower rows of pistons were in opposite phases for balance. Despite its height, the engine was less than half a meter wide and weighed only 34 kilograms together with the 4-speed gearbox. The claimed top speed of this motorcycle was 145 kilometers per hour, although the output power was not specified. However, Wöhler faced a number of problems with launching the model into production. By the way, Wöhler Lightfoe is somewhat similar to Brav Superior Golden Dream, except that the Superior used two crankshafts instead of a complex connecting rod system. But in October 1952, it was announced that the brand new 500 cubic centimeter Flatfoe would go into production in April of the following year. And although this ambitious goal was not achieved, in August of 1953, an experimental model was presented to the press. In November of the following year, it was shown to the public at the Earl Scott Show of 1954. The brand new overhead valve 4-cylinder engine was developed by Ron Wooler. He created a simpler layout. It was a flat V-shaped 4-cylinder engine that produced 32 horsepower. However, due to high production costs and other difficulties, the Wooler Flat 4 was produced in very limited numbers. And why have I been talking for the last couple of minutes not about the Boxer engine? And then, so that I could clearly show you a flat V4 and how it differs from a Boxer engine. Lastly, in this chapter, I'll briefly discuss French and Belgian Boxer engines. So, there was a French company called Nomron, and even back in World War I, it became famous for its aircraft engines. After the war ended, with a sharp drop in demand for those very engines, the company's management faced a tough challenge. What should they produce? Nomron followed the same path as BMW. Recognizing their inexperience in motorcycle manufacturing, they chose to license from a specialist already well versed in the field. The choice fell on a rather unusual design for that time, the ABC motorcycle, designed by the well-known engineer Grenville Bradshaw. The ABC model was the first to have the engine installed with the cylinders positioned across the frame. From 1920 to 1924, the company produced about 3,000 of these unusual and rather expensive machines, and then switched to manufacturing more conventional motorcycles. But the love for the Boxer engine didn't go anywhere, and in 1930 a new generation of machines debuted with 500cc two-cylinder Boxer engines. They were distinguished by a shaft drive to the rear wheel, a duplex frame made of stamped elements, and a front parallelogram fork with strong springs, also manufactured using stamping methods. The pinnacle of this family's development was the Gnome Rayon 750 presented at the Paris Motor Show in October 1935, featuring a two-cylinder overhead valve Boxer engine with a displacement of 724 cubic centimeters producing 34 horsepower. At that time, it was one of the most powerful and fastest motorcycles in the world. In the solo version, the machine could accelerate up to 150 km per hour, and with the lightweight Bernadette Sport sidecar up to 110. In advertising its motorcycles, the Nomron company always emphasized the aviation quality of its products. To support this claim, the company encouraged its machines to participate in all sorts of long-distance runs and record-setting races. So, on September 5th, 1936, racer Bernard, riding a 750 IX with a sidecar, overtook the Orient Express on the Budapest-Paris route, covering 322 miles in 23 hours and 28 minutes. No less fame was gained by two record-setting sessions held with the support of the Yako oil manufacturer at the Montlhéry track in 1937 and 1939. Among the most notable records set during these sessions were 24 hours at an average speed of 84.9 miles per hour and 50,000 kilometers at an average speed of 68 miles per hour. In total, the Nomron 750X motorcycle set 108 world records, some of which have not been broken to this day. The last batch of these excellent motorcycles was produced in 1942 when the Vichy government ordered a series of 50 motorcycles for the escort service of the country's top officials. These motorcycles, known as the Nomron XC40, were used until 1952, escorting the motorcades not only of Henri Pétain, but also Charles de Gaulle and Vincent Auriol. Before the start of World War II, the company also introduced a military motorcycle with a side valve opposed engine, the Model AX2. And this was one of the first mass-produced military motorcycle models in the world, with a driven sidecar wheel. The sidecar's payload capacity was 924.3 pounds. In addition to the standard version, the French army used a large number of special combat sidecars, medical, chemical protection, and so on. The model of the motorcycle X2 was produced in large quantities almost until the end of World War II, not only by the company Nomron, but also by the motorcycle company Terra. The Nomron X2 could be found in almost all the armies that fought on both sides of the front line. Belgian motorcycles with opposed engines appeared thanks to preparations for World War II. The best strategists of that time were preparing for a mobile war, a mechanized war. One of them was the Belgian Minister of Defense, Lieutenant General Henri Denis. He launched several projects for the rearmament and mechanization of the army, including a competition for a heavy army motorcycle. The requirements for the fire support, communications, and supply vehicle were quite strict. But this did not discourage the Belgian company FN Fabrique Nationale, which presented its own version, the heavy motorcycle FN M12, at the beginning of 1937. It was a 1-liter opposed engine with a moderate power output of 22 horsepower. The compression ratio of 5:1 allowed it to use gasoline of any quality. The gearbox included 4 forward gears, a reverse gear, and a low gear. There was a drive to the sidecar wheel, for the first time on a military motorcycle. By the way, the sidecar wheel drive system was proposed almost simultaneously and independently by 2 inventors, the Russian Peter Mazharov and the Englishman Henry Boan. At the end of 1929, Mazharov built an experimental motorcycle, the Izhezh 2, with a drive to the sidecar wheel, while Boan created the first real motorcycle with a similar drive, which he produced in a small series under the Boan brand from 1930 to 1936. The civilian version of the FN M12 Grand Tourisme debuted at the Brussels Auto Show in January 1937, which never went into mass production. In the spring of 1937, the military version of the FN M12 anti-ship missile was presented for army trials. The motorcycles covered 6,000 kilometers, including sandy and rocky off-road terrain, in 6 days and received an excellent rating. In July 1938, the FN M12 SM motorcycle was presented at the International Army Motorcycle Competition in SPA. After that, its exports abroad began. Most of the vehicles were purchased by Iran, 51 motorcycles, and Greece, 33. Several motorcycles ended up in Germany, where they were thoroughly studied. Thus, the German company used some of these technical solutions when designing their own army motorcycle, the KS 750. Based on the successful M12, the company later developed the FN 12T3 tricycle, also known as the FN Tri-K, which was designed to solve logistical tasks in the army, namely the delivery and transport of cargo, with a total weight of up to 700 kilograms. Thanks to the same competition for the development of an army motorcycle in Belgium, the Sorolea 38H appeared. It was an excellent army motorcycle with a 1-liter opposed engine. However, the overwhelming majority of these approximately 300 vehicles ended up in the ranks of the Wehrmacht after the capitulation of Belgium and were later lost on the Eastern Front. We've now arrived at the renowned motorcycle manufacturer BMW. BMW has been the most successful in creating boxers throughout the entire history of motorcycle manufacturing. The discussion about them is set aside for a separate chapter. This company and its history definitely deserve a separate large-scale story, but that will be sometime later. Now we'll focus on the opposed engines, and not even all of them, but only on the key models in the brand's history. Have you heard about the German Helios motorcycles? Well, I hadn't heard of them either before working on this story. So, this opposed engine was built by the Bayerische Motorenwerke company in 1921, 1922 by Gustav Otto's firm, which BMW would absorb in 1922. And yes, this is the same engine that was used on the Victoria KR1, and the roots of this engine come from Foggy Albion, namely from Douglas. The so-called predecessor of BMW motorcycles, the Helios, was improved by Max Friss and Martin Stoll, who equipped it with a transverse opposed engine. The model was called the R32, and it was the first motorcycle developed in-house by BMW. The engine of this model produced 8.5 horsepower, and by 1926, 3,000 units of the R32 had already been built. Martin Stoller is a very significant figure in history. Before the war, he owned his own workshop in Munich, and later became a well-known motorcycle designer. His achievement is considered to be convincing the management of BMW to start developing new power units for motorcycles. Already in 1925, the next motorcycle model, the R37, was released. It differed from the first BMW model by having a radically improved opposed engine with 16 horsepower. In the same year, the sports model achieved 91 victories in various categories and won 2 championship titles. And in 1926, it won a gold medal at the Fédération Internationale de Motocyclisme competitions in Great Britain. In 1927-28, the company's engineers were working on equipping the motorcycle with a supercharger. By 1929, the machine was ready, and this motorcycle, called WR750 with Ernst Henner at the handlebars, set the first speed record for BMW on September 19, 1929, 216.75 km per hour. Record runs with supercharged engines continued until 1937. A year later, the record reached 221.5 kilometers per hour. In 1930, it was 238.3, and in 1937, the same Ernst Henner, on a new BMW motorcycle with an overhead valve engine of 500 cubic centimeters and a power of 108 horsepower, reached a maximum speed, 279.5 kilometers per hour. This record stood for 14 years. In 1938, Georg Meyer became the European champion in the 500cc class motorcycle races on a supercharged motorcycle. The next year, he won the famous Tourist Trophy race on the Isle of Man. It turns out that already in its first decade, the company made a serious name for itself with the reliability of its equipment and various victories. And already at the turn of the 20s and 30s, it was producing a whole lineup of opposed-engine motorcycles. If in the 1910s many looked up to Douglas when designing Boxers, then in the 30s and 40s many would look up to BMW. Since the mid-1930s, Germany, including the company BMW, was preparing its entire industry for war. In addition to civilian models, motorcycles were developed for service in the Wehrmacht. The models R12 and the R71 were intended for these purposes. But with the beginning of World War II in 1939, German engineers gained access to captured Belgian and French Boxer engines. Yes, the very same ones from the previous chapter. The Germans truly appreciated both the sidecar wheel drive and other engineering solutions of their continental neighbors. A decision to create a special army motorcycle immediately followed. In 1941, that model became the R75. If you're tempted to criticize the Soviet Union, claiming we lacked originality and merely imitated BMW, remember this. BMW readily used solutions from Douglas, FN and Gnome Rhone. BMW 75 was rightfully one of the most advanced motorcycles with a sidecar wheel drive at that time. Overhead valve engine, 750cc, 26 horsepower, the first motorcycle to feature an automatic ignition timing adjustment mechanism, 4-speed gearbox with reverse gear, reduction gear, differential with locking mechanism, and a shared hydraulic brake for the rear wheel and the sidecar wheel. Many other manufacturers took the Germans' technology as an example. So, during World War II, American General Motors created a prototype of the Delco military tricycle, and Harley produced about 1,000 units of the XA model. In the late 1940s, Swiss company Condor produced the Opposita model for the army, manufacturing 580 units post-war, under the impression of German technology, or maybe Belgian as well. The war ended in 1945 and, as we know, not in favor of the Germans. The restrictions imposed by the Allies after the war did not allow Germany to build heavy motorcycles, only single-cylinder ones with limited engine capacity. But in 1947 there was a very interesting attempt to build a miniature Boxer engine, the R10. More about it in the next chapter. The company would return to serial Boxer engines in 1950 with the model R51/2. BMW was fortunate during that period. The Munich division ended up in the American occupation zone. In 1948, the motorcycle manufacturer gained access to foreign markets, including the American one. For avid athletes, already in 1951, the R68 model was developed with a top speed of over 160 km per hour. In the 50s and 60s, a whole range of Boxer engines followed once again. They were all just as renowned for their reliability and technologically kept up with the times. The machines participated in many competitions, but by the late 60s, the Boxer engine's potential was no longer sufficient. In many countries, this equipment served in the traffic police and as escort vehicles. In 1973, the company released the R96 and its sports version, the R90S, both with a 900cc overhead valve Boxer engine, marking the first time they crossed the 750cc mark. 4 years later, a 1-liter model was introduced. In the late 1970s, BMW ventured into off-road sports, specifically rally racing. That's how the legendary GS family from BMW was born, and it all started with the R80 GS model in 1980. This motorcycle quickly set out to conquer the Paris-Dakar rally. BMW was perfect for this. The Boxer engine had good cooling, strong low-end torque, and gave the motorcycle a low center of gravity. The drive shaft was a clear advantage when used in the desert. And the first in the Goose family won the Dakar 4 times in 1981, 1983, 1984 and 1985. Is it even necessary to say that the GS series became incredibly popular? Many motorcycle enthusiasts craved adventure, though not necessarily on the scale of the Dakar Rally. And BMW gave them those emotions. BMW invented the touring enduro niche, which has become increasingly popular in the 21st century. The company still dominates the market with modern models like the R 2,641 pounds S and R 1,377.45 pounds S. The opposed engine is also used in both tourers and road motorcycles. Like any company, BMW experiments. An interesting experiment was the Model Eichpidva, which appeared in 2008 and remained on the assembly line for 4 years. This is a sports bike with an opposed 1200cc, 130 horsepower engine and 115 Nm of torque. There was also an enduro version of Eichpidva, and here the characteristics of the opposed engine are more suitable specifically for enduro, and the sports bike turned out to be an unsuccessful experiment. Nowadays, BMW is one of those brands that has kept opposed motorcycles in its lineup and continues to develop them. And BMW is the company that throughout its history has probably offered the largest number of Boxer models. Usually when we use the term opposed motorcycle, we mean rather heavy machines with a substantial engine displacement. At least 650 cubic centimeters on domestic sidecars, and often a liter or more. Yes, it all started with a modest 200 cubic centimeters back in 1905, but already in the 1930s the engine displacement of such motors was rarely below 500. However, the history of motorcycle manufacturing also remembers some rather elegant small displacement motorcycles with opposed engines from the mid-20th century. What do we know about the late 1940s and early 1950s? This was the time just after World War II, and in post-war Europe, the Soviet Union, Japan and so on, a car was considered a luxury item. As personal transport, an ordinary person could afford either a bicycle or a simple small displacement motorcycle. Therefore, during this period, motorcycle companies began to pay less attention to luxurious, large pre-war models and focused on what was necessary for the general public. More precisely, it depended on what the masses could afford. The best-selling bikes of this era were basic two-stroke, single-cylinder models such as the widely copied DKW RT 125 produced in the Soviet Union, Britain and Japan. However, in their attempts to conquer this market, engineers sometimes came up with very interesting and complex designs, including opposed engines. Here's a small selection which includes both two-stroke and four-stroke Boxer engines. The BMW R10 is a highly unique, compact opposed engine motorcycle and the first to feature a two-stroke engine. Before this, two-stroke Boxers were not installed on motorcycles, at least there are no earlier mentions of them. In 1947, the idea of a miniature opposed engine came to the minds of engineers. We're talking about an enterprise in Munich, which was part of the American occupation zone. Post-war Germany required affordable and lightweight equipment, which was the priority in developing the BMW R10. The equipment turned out to be simple, yet incredibly elegant. It was equipped with a 123 cubic centimeter, two-stroke, two-cylinder Boxer engine that produced 5 horsepower. Above the crankshaft in the engine block there was a 3-speed gearbox, and the power to the rear wheel was transmitted by a drive shaft. Several prototypes were built. The first one had a rigid rear end, while a later version featured a rear wheel with a spring suspension. The project was closed at the prototype stage because a lucrative American market opened up for BMW and the focus shifted to a more expensive segment of equipment. Since we're talking about two-stroke machines, here's another one for you. The IFA BK 350 motorcycle emerged in post-war Germany. BK referred to Boxer cardan. The air-cooled two-stroke opposed engine was initially created during the war by DKW. It was designed for the Luftwaffe as a starter for jet engines and had a displacement of 250 cubic centimeters. After some minor modifications and increasing the displacement to 343.5 cubic centimeters, this engine was used for civilian purposes. With its power of 15 horsepower and later versions producing 17, it was able to accelerate the 142 kilogram motorcycle to 120 kilometers per hour using a 3-speed gearbox. The motorcycle was first presented to the public in 1951, but it only went into production starting from 52. In its final years, the IFA factory was renamed MZ. Consequently, the motorcycle was named MZD BK350. The production of this model was stopped in 1959. A total of about 40,000 of these machines were produced. BK 350 was produced not only in Germany. A number of these motorcycles were produced by the Japanese company Olympus Krone. The model was called Type H, and the motorcycle was produced from 56 to 62. Let's move to Britain of those years. After the war, the transportation issue was also acute there. Eugene Goodman, co-owner and chief designer of the Velos company, decided that the time had come for his project. The project was called the Little Engine. The company primarily made 350cc and 500cc single-cylinder engines then, but people needed smaller, cheaper options. The Little Engine debuted in 1948 at the British Motor Show. The machine was equipped with a 150 cubic centimeter, two-cylinder, four-stroke opposed engine with liquid cooling. Since the cylinders were recessed into the crankcase and a side valve timing system was used, the engine turned out not to be particularly wide. The frame was based on a load-bearing box-type structure, to which the power unit was mounted on rubber silent blocks. To attract a non-motorcycle audience, the creators abandoned foot-operated gear shifting. The owners of the company, the Goodman brothers, fanatically believed in the success of their venture and planned to tailor almost all of their production to this model. But the public received the new product rather coolly. First of all, not every Briton wanted to get acquainted with such an unusual and rather complex design. Secondly, the cart was frankly underpowered. The 6 HP opposed engine barely accelerated the vehicle to 49.7 miles ch.
But most importantly, the Velocette Li cost £126, while for 76 you could buy the BS A Bantam, a copy of the German DKW RT 125. The guy was on his way to success. It didn't work out, he wasn't lucky.
The company quickly learned from its mistakes, and at the end of 1950 introduced the Velocette L1 Mark II. In this model, the engine capacity rose to 192cc power to 8 HP and top speed to 55.93 miles at Sechechorbo. The manufacturers managed to slightly lower the price, but the situation with Little Engine didn't really change. The police saved the vehicle. The department was delighted with the equipment. They decided that for patrolling provincial streets, the performance would be sufficient. The protection from splashes and bad weather, the ability to store equipment in side bags, and the low noise level of the vehicle also appealed to the law enforcement officers. A little later, the Postal Service came to the rescue. From that moment on, most of the LE bicycles went straight from the assembly line into service. In the mid-50s, engineers decided to fill the gap between the weak Little Engine and the single-barrel sports model LI. This bicycle debuted at the end of 56 under the name Valiant. The machine was created almost from scratch. They installed an overhead valve opposed engine which retained a displacement of 192 cubic centimeters and a power output of 12 horsepower, abandoned liquid cooling, added a kickstarter and equipped the machine with a new 4-speed KPP transmission. Unfortunately, neither the catchy name nor the strong appearance could withstand the main drawback of the machine, the high price. Until the early 70s, the company tried to boost sales of opposed engines. In 1960, they even released a model with a two-stroke, 250 cubic centimeter engine called Viceroy. This machine did not have power issues like the LE. Viceroy could confidently accelerate up to 110 km per hour, and in addition, it had an advanced 12-volt electrical system and an electric starter for that time. However, the model ultimately failed to gain popularity due to its high price. By the end of the 60s, the police were already mostly driving cars, and the demand for LE had dropped altogether. In 1970, the final small opposed engine was produced, and the Velos company shut down a year later. Another small opposed engine comes from sunny Spain, Mavisa, a Catalan motorcycle brand that, for a short period, produced motorcycles from 1953 to 1960. The business was run by two brothers, Manuel and Villavicente. In 1957, Mavisa presented the 250 Sport model at the exhibition in Barcelona. Mavisa 250 Sport. It was equipped with a two-stroke opposed engine developed by Villa with a displacement of 250 cc and a power output of 14 horsepower. The creators had to spend about 2 years developing and testing prototypes in order to reach the production of a more or less reliable motorcycle. However, most of these designs had the same significant problem. A small displacement opposed motorcycle costs 1.5 times more than single-cylinder and inline twin motorcycles of a similar class. For this reason, Mavisa 250 Sport was produced in only 8 units. A little earlier, a similar prototype was made by the Hungarian company Pannonia. In 1951, the RB 250 was built with a 2-stroke engine, which was developed by one of the factory workers who was passionate about aircraft modeling and knew about opposed engines firsthand. Pannonia released a trial batch of a couple dozen units, and that was the end of the RB 250's story. The German company Hoffmann began its existence in 1949. In 1951, Richard Kuyken, one of Germany's leading motorcycle designers, presented a beautiful 246cc opposed motorcycle that resembled a BMW. The model was called the Hoffmann Governor. In 1953, the engine displacement was increased to 300cc and the model was renamed the S300. Unfortunately, despite these updates, the company closed in 1954. Partly due to the high cost of assembly and development, a weak domestic market, and also because of a legal dispute with Vespa over their licensing agreement. In 1954, just before closing, Hoffmann also built the microcar Autocabine 250 with an opposed engine. It was a copy of the Isetta, the production rights for which belonged to BMW. Having failed to sell even 100 of the produced microcars, Hoffmann was facing a lawsuit. Well, and finally, a couple of Italians. The Industria Meccanica Napoletana Rocket 200, a small car with a 200cc engine and 11 horsepower, was introduced by Industria Meccanica Napoletana in 1956. But the most interesting thing about this machine is the block, the engine, gearbox, drive shaft, plus the attachments, footrests, exhaust and stand actually form a swing arm, and all of this is attached to the frame and shock absorbers with a single axle. The second is the Capriolo 150, 4-stroke, 175 cubic centimeters, 7.5 horsepower and chain drive to the wheel. There is also a series of miniature boxer engines from Japan, but I will talk about them in a separate chapter about Japanese boxer motorcycles. All these miniature boxer motorcycles are very cute. However, as you can see, technical perfection and aesthetics are far from being the main factors for a model's success. Practically all of these mini boxes lost out to simpler and cheaper motorcycle designs in their time. Nearly 2 hours into the story, we've finally reached the topic of Soviet Union's boxer motorcycles. In this chapter, I don't want to focus too much on the mass-produced models. The Dnepr MT-10 or the Ural M67 are already well known to the general public. I want to focus more on the rare and interesting developments. The history of domestic motorcycles with horizontally opposed engines began in 1939 when the Soviet government, concerned about Hitler's ambitions to expand German territories, began rearming the Red Army. The Germans were quite successful in developing heavy motorcycles, so in order to save time, it was decided to adapt an existing engineering solution. Union of Soviet Socialist Republics Foreign Minister Molotov secretly bought 5 BMW 71 motorcycles from Sweden. And Soviet engineers got to work. In the winter of '41, field tests of the new M72 motorcycle were conducted. Initially, production of the M72 was organized in Moscow and at several other enterprises across the country. In particular, some components of the M72 were produced at the Leningrad Krasny Oktyabr plant. The production was moved to Irpin when the Wehrmacht troops came dangerously close to Moscow. And after the war, a decision was made to start the production of opposed motorcycles in Kiev as well. One of the most interesting opposed machines created during the war years was the motorcycle TMZ-53. It was developed in Tyumen. At the end of November 1941, the evacuated Taganrog tool plant arrived here. In 1942, the company, facing staff and equipment shortages, only delivered 187 AM600 motorcycles to the military. They were never able to establish serial production of the M72 at the new Tyumen motorcycle plant. In 42 workers created a prototype of the TMZ-53 using German expertise. It was a heavy liter class opposed engine with drive to the sidecar wheel. The TMZ-53 was tested together with the German motorcycles BMW 75 and Sundap KS 750. The Red Army had plenty of such trophies. The tests were conducted in both summer and winter, including in difficult road conditions. In terms of performance, these motorcycles were equivalent, and off-road, the model designed in Tyumen even showed better results, especially on steep climbs. The TMZ 53 only lost to the famous Sundap in terms of fuel efficiency and range. A smaller fuel tank was installed on the model. The tests conducted demonstrated that the 53rd could be used to tow a 45mm cannon, and under certain conditions, it could even pull a 76mm artillery system. Unfortunately, TMZ 53, despite the promising development, turned out to be very difficult to manufacture. It was not possible to master its production under wartime conditions. All the more surprising is that out of the 2 experimental models produced, at least one has survived to this day, and today it can be seen in the collection of the Polytechnic Museum in Moscow. It is also worth noting that work with overhead valve engines was already being carried out during wartime. Thus, a prototype of the M7375 was developed, featuring a drive to the sidecar wheel. The accumulated experience allowed the introduction of racing motorcycles in the late 1940s post-war period, including the Irbitsky M75, the Serpukovsky M76, and the Gorkovsky M80. The engines of this equipment produced power in the range of 40 to 50 horsepower, which allowed them to reach speeds of up to 180 km per hour. Some work was also done for a while on compressor-type opposed engines, and in this field, Nikolai Shumilkin achieved the greatest success. By the way, there is a separate feature about his motorcycles on the channel. His motorcycle, Kometa 2, was based on the BMW R51, on which a Zola compressor was installed. On this motorcycle, in 1946, Shumilkin rode 1 kilometer from a standing start at an average speed of 105 miles per hour, which was just below the all-Union record. Nikolai beat it only in 48, accelerating to 109 miles per hour. By 1952, Nikolai Nikiforovich had increased the engine power to 70 horsepower, and on the Kometa 2 with a tail fairing, he accelerated to 131.5 miles per hour. A year and a half later, the streamlined 90 horsepower Kometa 3 appeared, on which Nikolai showed a result of 138.96 miles per hour. However, soon the legendary mechanic left motorsport due to his advanced age. By that time, namely by the end of the 50s, 2 enterprises in the Soviet Union were mass-producing opposed motorcycles, the Kiev and Irbit motorcycle factories. In addition to standard motorcycles, a small number of sports machines were produced for participation in all-Union competitions. These were vehicles designed both for road racing and for sidecar motocross. In this work, Serpukhov VNII Motoprom significantly assisted the enterprises. The Irbit factory had 2 interesting developments, the first being the EM100. The motorcycle was intended for use by the police. In 1962, the Central Committee of the Communist Party of the Soviet Union proposed creating a motorcycle that would outperform other vehicles in speed. The requirements were set: 150 km per hour for the solo version and 120 for the sidecar version. The first 2 prototypes, with and without a sidecar, were assembled by fall 1963. By January 1964, they were tested in a 10,000-kilometer run. Special attention was given to the 1040 cubic centimeter engine. Initially, it produced 40 horsepower, but to meet the set requirements for maximum speed, its power was increased to 50. In December of '67, a small batch of M-Stow was sent to the Moscow branch of the State Automobile Inspectorate. The estimated volume of orders for this model was supposed to be 1,500 units per year. The factory, loaded with mass production and lacking a small batch workshop, was not ready to manufacture such a quantity of new vehicles. As an alternative, the factory workers offered the police the M63P model, the production of which turned out to be much simpler and cheaper. The M63PE fully satisfied the police officers in terms of speed. The single-seater reached 143 km per hour. The second promising model is the Ural M73. By the early 70s, the idea had matured at IMZ to release a motorcycle to the market that was more in line with the times than the archaic serial models, whose roots went back to the 30s. Since 1970, the VNII Motoprom Institute in Serpukhov had been developing a promising motorcycle called the VNII 831, with an inline 2-cylinder 650 cubic centimeter engine producing 60 horsepower. But it turned out that launching the production of such a dynamic machine was impossible due to the lack of high-quality components manufacturing, namely rubber, brake discs, and so on. In December 1976, the Central Committee of the Communist Party of the Soviet Union and the Council of Ministers issued a resolution to modernize MZ, aiming to boost annual motorcycle production to 200,000 units. In the development of this resolution, a technical assignment was issued, defining the main requirements for the new motorcycle model. A two-cylinder, opposed, four-stroke, 750cc engine with at least 45 horsepower and fuel consumption of 2.2 gallons per 62 miles or less. The most fatal point of the technical assignment was the requirement to maintain unification with existing models by no less than 75%. The first prototype models of the M73 motorcycle were assembled by January 1978. They successfully passed the full cycle of tests and were recommended for production. The factory began preparing to master the new model, purchasing equipment, and clearing the necessary territory for expansion. However, the factory workers soon discovered that the new 5-year plan did not allocate any funds for modernizing the enterprise. A heavy enduro-inspired prototype was under development in Kyiv. This was the Dnipro 95802 Dynamite model. Apparently, the idea for such a motorcycle emerged after the success of the BMW R80GS model. The Dnipro 95802 turned out to be a very interesting design at that time. A 1-liter, 70-horsepower engine, 4-valve cylinder heads, a monoshock absorber in the rear wheel suspension, a front disc brake, and suspension travel of 200 millimeters. Dynamite could have been a very decent machine, but it got stuck in the testing phase in the mid-80s, and the collapse of the Soviet state was already looming on the horizon. The motorcycle prototype was never mass-produced, like many other intriguing designs. KMZ produced escort motorcycles as one of its product lines. The factory began with specially prepared EM72 models and ended with the Dnieper 14.9 model by the late 1980s. Another niche was motocross and road racing machines. I won't talk about all of them, but there are a couple of very interesting motorcycles with sidecars that definitely need to be mentioned. As you know from the chapter about BMW, by the end of the 60s, the two-cylinder 4-stroke boxer engine was no longer relevant in road racing. In the early 70s, this fact was also understood at KMZ. In 1977, factory racer Alexander Serpov and engineer Dmitry Skazan introduced a groundbreaking new racing motorcycle. And they equipped this machine with a 2-stroke 4-cylinder boxer engine, JLM4, produced by the Ulyanovsk motor plant. Initially, this engine was used on boats and produced 100 horsepower. The designers at the KMZ plant significantly modified it. The power was reduced to 80 horsepower, while at the same time leveling out the torque curve. The motorcycle was named SHA 500. It's amazing that in its equipped state, this machine weighed only 155 kilograms, even though the tank held 28 liters of fuel and the cooling system contained 10 liters of fluid. The maximum speed of this sidecar was 220 kilometers per hour. It is known that the motorcycle had several generations, but for its later versions there is no technical data, only photographs. A little later, the Dnieper S-Chassis model was created, in which the power of the same engine was increased to 95 horsepower, and the maximum speed thus rose to 250 kilometers per hour. Izhevsk motorcycles are well known to us all. But not everyone knows that the factory made an attempt to master the production of an opposed motorcycle as part of the development of 500 cubic models. The decision was made in 1979. The Ministry of Defense Industry proposed to start the development of a 4-stroke opposed engine, together with the company Java and specialists from VNII Motoprom.
Yes, Java also got involved in the development of opposed engines.
At the same time, the Czechoslovak company had already tried its hand in this field back in 1939. In the 80s, together with Izhmash, Java developed the model Piazza Type 824. These two motorcycles did not differ significantly from each other. The 500 cubic centimeter opposed engine produced about 33 to 36 horsepower and was paired with a 5-speed gearbox. Both an electric starter and a kickstarter were present. The machines also met an unfortunate fate. Java produced about 10 units and Izh made even fewer. Did you know that the Chinese manufactured boxer engines? Chengjiang is a copy of the original Soviet model M72. It so happened that these motorcycles began to be produced in Nanchang in the late 50s with the support of the Soviet Union. Different sources give dates ranging from 57 to 61. In September of 66, production of the overhead valve engine began, but due to the surplus of side valve engines, they continued to be installed on motorcycles until 72. In December of 80, in response to the military police's purchase of motorcycles, an experimental batch of 900 cubic engines was produced. Nowadays, the third generation of Changjiang motorcycles does not use a boxer engine, preferring an inline twin. Finally, in this chapter, I want to draw your attention to the fact that motorcycle boxer engines in the Union of Soviet Socialist Republics were used not only on two-wheeled vehicles. It is known at least about two models of helicopters with these engines, Ka-8 and Irkutyanin. The first Kamov helicopter, the Ka-8, took off on November 12, 1947, and was equipped with a Serpukov boxer engine, the M75, which was modified for forced cooling. The motorcycle boxer engine was enough to accelerate the helicopter up to 80 km per hour. Another helicopter was developed by the Kharkiv Aviation Institute in 1970. The experimental aircraft was named KHAI-27 Kharkovchanin and was equipped with an engine from the M63 motorcycle. The light two-seater helicopter KHAI-27 was created at the Student Design Bureau of KHAI. The flight weight was 300 kilograms, the maximum speed was 90 kilometers per hour, and the estimated ceiling was 2,000 meters. It is also worth noting that many homemade and factory aerosleds and motosleds in the Soviet Union were equipped with motorcycle boxer engines, since this was the most powerful of the available engines. During World War II, IEMZ developed a tracked vehicle with an EM72 engine and the NAMIE MES1 motorsleds, which were built in 1942. The EME-7 engine was installed on light aerosleds such as the NKLA 3, 4, RF-7, RF-1, 2, and so on. However, we'll talk about aerosleds in a separate episode sometime. In summary, the domestic motorcycle industry had potential for success from the end of the Great Patriotic War until the 1970s. The designers stood on the shoulders of giants like B.M. Eduyu and brought interesting ideas to life in metal. However, in the end, the polymers were missed, the country fell apart, and among the manufacturers of opposed motorcycles, only IMZ survived. Even then, they make small batches, like toys for wealthy markets in the United States of America, Canada, Australia, etc. Really, a toy? Here's a Ural with a bottle of vodka and a shovel in the sidecar, and here's a limited edition with a solar panel and a drone. Would you also attach a Matryoshka doll? Damn, why did I give them that idea? What is the most famous motorcycle with an opposed engine from the land of the rising sun? Of course, Honda Goldwing. This legendary machine has been produced since 1974 and to this day remains the company's flagship in the luxury touring segment. And it all began at the turn of the late 60s and early 70s. It was at that time that the management of Honda decided to create a fast and powerful heavyweight touring motorcycle. To develop the first Goldwing, a team of designers and engineers was assembled under the leadership of Saitiro Irimadziri, who in the 60s had developed 5- and 6-cylinder engines for Honda racing motorcycles. Their work led to the creation of a top-secret prototype called M1 in 1973. The concept machine was equipped with a flat 6-cylinder engine and a shaft drive, features that would later become the hallmark of the Goldwing series. The flat 6 was chosen for a reason. It is the most balanced compared to a flat twin or a flat 4. The 1.5-liter engine prototype had issues due to its lengthy design, making it impossible to provide a comfortable seating position for the rider. A tourer must prioritize comfort on long rides. To significantly reduce the production model's length, they removed 2 cylinders from the engine. The first production Golda of 1974 was equipped with a 1-liter 4-cylinder boxer engine. Over time, the engine displacement grew along with the popularity of the machine. The 1100 model appeared, and a little later, the 1200. And this continued until 1987, when Honda finally used a 6-cylinder boxer engine on a production motorcycle. The process of creating the GL 1500 model was the most complex and comprehensive in the company's history at that time. But it was worth it. Goldwing is still the benchmark of quality and comfort in the luxury touring niche and has a huge following all over the world. And since 1987, an integral part of this machine has been the 6-cylinder boxer engine. If you think that Japanese motorcycles with such an engine ended there, you're mistaken. Would it ever occur to you to equip a motor scooter with a Boxer engine? It did occur to Seiichiro Honda. The Honda Juno is a line of small displacement vehicles that began production in 1954. However, the 1954 K50 model was problematic, heavy and underpowered. In the early 60s, work began on a new version of the motor scooter, and in November 1961, the Juno M80 model was introduced, which went into production a year later. The M80 received a 125cc 4-stroke overhead valve opposed engine with air cooling, and yes, this is the smallest opposed engine ever put on a motorcycle. Juno was a project where the engineers were given complete freedom of action, so they got as creative as they could. In the middle of '62, the M85 model appeared, whose engine displacement was increased to 170 sir. The specifications were as follows: 11 horsepower at 125 and 12 at 170. Obviously, the M80 and M85 equipped with electric starters comfortable and stable on the road were interesting to the public. The problem was the price. The M80 cost 159,000 yen, and the M85 was 10,000 more expensive. Technically very advanced and original, these scooters had no chance against the products from large industrial groups such as Fuji or Mitsubishi, whose price tag was 130,000 yen. Another Japanese company that succeeded in building opposed motorcycles was the Maruso Lilac Company. In the 1950s, Maruso Lilac, which was located next to Honda in the city of Hamamatsu, released two models of opposed motorcycles with an engine displacement of 350cc, the Lilac KW Dragon and the Lilac SW Lancer. The opposed engines were side valve and produced 12 horsepower in both versions. The machine weighed around 160 kilograms and could accelerate up to 110 kilometers per hour. At the end of the 50s, the company faced a severe crisis. In '63, it was reorganized and returned to operation in 1964. Now it was a much smaller production than before. At the Tokyo Motor Show in '64, the company presented two prototypes of miniature Boxer engines, Lilac C103 and C105, with 125 and 160 cubic centimeter engines. But these models did not go into production. At that time, the focus was on creating a large displacement Boxer twin for the United States market. In '64, production began on the Maruso ST with a 500 cubic centimeter, 36 horsepower overhead valve Boxer engine. In 2 years, about 600 units were built, most of which were shipped overseas. In the United States of America, this model was initially named Imperial and a little later ST. At first glance, the engine looks like a copy of BMW, but in reality, only some internal parts resembled those of BMW. Lilac tried not to violate BMW's patents, used a completely different ignition and electrical system, and also implemented its own transmission and clutch. In '66, the Maruso Magnum model debuted, which was in many ways a reworked ST with its power increased to 40 horsepower. In '66, only 180 Magnums were produced. Lilac's final motorcycle was the Magnum Electro. In addition to the Kickstarter, they used an electric starter in it. BMW will present its motorcycle with an electric starter only 3 years later. Unfortunately, suffering losses, the company Maruso soon went bankrupt. In this chapter, I will tell you about some small batch and even completely homemade motorcycles with an opposed engine. And first on my list is the Racing Koenig 500 Grand Prix, which was ridden by Kim Newcomb. The Koenig engine was a 2-stroke, 4-cylinder opposed unit with a displacement of 494 cubic centimeters, boasting impressive power and a strong reputation in hydroplane racing. Yes, its layout is quite similar to the GLM4 motorcycle's Dnepr SSHA 500. The Koenig 500 Grand Prix motorcycle appeared in 1969, but it was refined for a couple more years. As a result, the maximum power of its engine was 75 horsepower. On this motorcycle, Newcomb achieved significant success in the racing seasons of '71 and '72. However, he tragically died on his motorcycle during a race at the Silverstone track in '73. Production of these motorcycles ceased in the mid-'70s, after about 100 units had been built, including some with sidecars. And here is an interesting homemade creation from France from the early 70s. One inventive motorcyclist named Jean-Paul Boucher decided to put into production a superbike with a flat twin engine from a Panhard PL17 car. Jean-Paul built the first Moto Tigre Panhard machine in 1969. Jean-Paul Boucher's first creation turned out to be quite bulky and heavy, so the model was further refined. They started using the engine as a stressed member of the frame, and the construction was made lighter. The motorcycle, originally built for racing, was powered by a 72 HP Panhard 24 engine. The motorcycle, with a dry weight of 145 kilograms, could accelerate to a top speed of 210 kilometers per hour. By 1975, the concept was revised towards tourism. The motorcycle received dual headlights, an electric starter, a double seat, and so on. The model was equipped with a 50 horsepower engine. In total, fewer than 10 of these machines were assembled, some of which have been preserved in museums. Since we're talking about France, here are a couple more opposed motorcycles that were developed there in the second half of the 70s. In this case, the approach was more serious. It all started with a competition held by the Ministry of Industry for the development of a motorcycle in 1978. The competition was won by a company made up of three guys named Louis Boccardo, Dominique Favario, and Thierry Grinch. They came up with the idea to put a car engine into a motorcycle frame. They chose a Citroën Flat 4 engine with a displacement of 1,300 cc. The machinery was produced at the BFG plant, but part of the responsibility for this engine was carried by the Motobecken company. It's not exactly known when the production of this motorcycle started and ended, but it was still appearing in some motorcycle catalogs as late as 1985. A total of about 450 units were produced, and around 100 of them were purchased by the police service. There was also a motorcycle called MF with a 650cc opposed twin engine. MF stands for Moto Franchise. Thanks to the enthusiasm of a Brit named Gordon Griffiths, an interesting opposed custom appeared. According to the information, Gordon was constantly building various customs. Around 1969, he got his hands on an old Sunbeam Estate from 1952. Griffiths experimented with this motorcycle, installing a Harley engine and later a Zook opposed engine. While reliable and torquey, the Zook lacks special charm, even in Africa. So, Gordon eventually settled on a 4-cylinder opposed engine from a Porsche 356, preferring its aesthetics and performance. This is how the unique Sunbeam Porsche Special 1300 motorcycle was created. A separate and very colorful branch of custom building is the so-called Volksmotor. Literally, it means people's motorcycle, but more accurately, it's a motorcycle with an engine from a Volkswagen. In most cases, it's an air-cooled opposed 4-cylinder engine from the Beetle. These custom bikes look quite unique. However, among them, there is one that was produced in series. This is the Amazonas Rhino from Brazil. Two handy guys, Luis Gomi and Jose Bestona from São Paulo, wanted to ride cool and big motorcycles. But in the 60s, it was practically impossible to buy anything solid in Brazil. Ordinary people had no money, and everything imported was taxed insanely. So the guys cobbled together motorcycles from whatever they had. And as an engine, they used a Volkswagen engine. And that's because it had already been produced in Brazil under license for more than 10 years. It was the most common engine in the country. From 78 to 78, about 450 units of the Amazon motorcycle with a 1600 engine were built, and only a very small number of the 1300cc version. A large portion of the motorcycles was provided to the police. History also records custom units featuring DAF engines. Or here's a 4-liter Alfa Romeo Boxer engine squeezed into the frame of a Falcone motorcycle. Just when you thought you knew all about Boxer engines, the Midwell Type 1 appears. The engine layout in this model was radically reimagined. Frenchman Olivier Midi, the creator of this marvel, offers an engine arrangement like the one used 100 years ago on the Douglas, but with a completely original twist. With the use of liquid cooling, the problem of overheating of the rear cylinder is eliminated. The engineer tilted the engine at a 25-degree angle, placing the gearbox under the rear cylinder. Olivier managed to create a motorcycle not only with a low center of gravity, but also with a reasonable length and a narrow silhouette. It took Midi nearly 20 years to fulfill his dream. His passion for motorcycles began at the age of 14. After getting his engineering degree, Midi began working as a designer at an automotive parts company. In 1992, he decided to start designing his own motorcycle. Initially, he worked on it during his free time in the evenings. Already in 1994, he received his first patent for the engine layout. After discovering no one would finance the project, he founded his own automotive parts company, which began supplying Citroën, Peugeot, and Renault assembly lines. By that time, he had enlisted the support of his older brother François. In 1999, at the Paris Motor Show, the first two Midwell 875 motorcycles were presented, although they had wooden mock-ups of the engines. The well-received project prompted the brothers to seek resources for its metal construction. Unfortunately, they were not able to find them elsewhere. And in 2001, they decided to focus exclusively on manufacturing auto components for 5 years in order to earn money for their ideas. Fortunately, the French automotive industry was thriving in those years, and in 2006 they were able to resume their motorcycle project. But by that time, the 875cc version of the engine seemed unsuccessful to them, and Olivier designed a new 1036cc version of the engine. Another 8 years passed before Midi's dream was crowned with success, and his 1-liter opposed marvel debuted before the public. This happened in the year 2014. The motorcycle was conceived as a work of art. There is practically no plastic in its construction, and it cost about 140,000 euros. It's clear that such equipment would be produced and sold in limited quantities, but the concept itself is worthy of attention. It's worth giving credit and mentioning the talented local enthusiasts. The first is Victor from Krasnodar region, who builds motorcycles from scratch. His creations include the Tesorok, the Megalodon, and an opposed cylinder motorcycle. The second are the guys from the Uralgon channel, who are currently working on creating an opposed 1150cc engine from scratch. At the end of this whole big story, it's worth figuring out the advantages and disadvantages of the opposed engine, both in the context of the engine itself and when it's used in motorcycles, and talk a bit about the balance of this type of engine. If we take the opposed engine as a kind of spherical horse in a vacuum, it's an ideal motor. It has a low center of gravity, good torque characteristics, and is one of the most balanced engines. The only real competitor to the opposed engine in terms of balance is probably the inline-6. Due to the mirror-like movement of the masses, vibrations are practically non-existent. But there are a few ifs. First of all, since in a boxer engine each connecting rod has its own crank pin, there is some offset between the cylinders and pistons relative to each other. In reality, there isn't a perfect mirror movement of the masses, although it is quite possible to achieve this. Here the animation clearly demonstrates a way to solve this issue. But if you start digging into real-life boxer engines, you are unlikely to find such a solution in practice. It all comes down to manufacturing complexity, or rather, to the cost of production. And in fact, it's easier to put up with minor vibrations that don't harm the design and are practically unnoticeable to the rider than to make an expensive component even more costly to produce. Secondly, an engine of this configuration is somewhat larger than inline and V-shaped engines. Thirdly, the most crucial drawback of the boxer engine. The entire motorcycle and automotive industry, and in fact all other industries, are primarily about money. The laws of economics and competition have not been cancelled by anyone. An opposed engine in production costs 1.5 times more than a comparable inline engine, resulting in more expensive equipment with this engine. As for the use of such engines on motorcycles, the obvious advantages of this design are a low center of gravity, low vibration levels, and good torque characteristics. This is particularly relevant for touring motorcycles and cruisers. However, there are also drawbacks. Have you noticed that if you twist the throttle on a BMW, the motorcycle tilts to the side? A similar effect can be observed on V-twins with a longitudinal engine layout. Moto Guzzi is an example. You can partially counteract this reactive torque by, for example, connecting the generator or gearbox in such a way that their moving masses rotate in the opposite direction. Secondly, no matter what anyone says, a boxer engine on a motorcycle, with cylinders positioned across the frame, is much more susceptible to serious damage if the motorcycle falls on its side. This problem can be partially solved with crash bars and other protective elements, but the fact remains. And finally, as I mentioned a couple of paragraphs ago, the main disadvantage of this engine is its high production cost. BMW, Honda, and Ural currently produce motorcycles with Boxer engines in series production. Small displacement Boxer engines turned out to be unprofitable and unable to compete with other types of technology. Motorcycles with larger Boxer engines can more or less fit into the price range of their niche. That's how things are, friends. With that, my couple of words about Boxer engines and their use in motorcycles come to an end. I probably couldn't tell you about all the interesting Boxer models in this episode, and it's possible that I made a mistake somewhere. However, if you're really curious, you'll be able to find what I didn't mention in this episode. I tried in these hour and a half to explain this topic in an interesting, clear, and humorous way. I hope I succeeded. At the time of releasing this episode, this is my most ambitious work. I hope it will resonate with you and gather a decent number of views. Well, you can help with all kinds of support. A like, a comment, a repost. You can also support financially if you wish. Thank you very much. This was the Krasmodo channel. See you next time.